Chapter 2 Geometry.
Point. A dot represents a point. It shows an exact position or location. It has no length and breadth. It is denoted by any capital letter as shown here. Line. A line has no endpoints. It can be measured. A line always goes in straight, no curves, and has no thickness. The arrow shows that it goes on and on in both directions. We denote the line AB as AB and as given here. It can be extended in both directions endlessly. Line segment. A line segment is a part of a line. It has two endpoints. It has a definite length. We denote the line segment AB as given here. A line has different types: vertical line, horizontal line, and a slanting line. Ray. Ray starts from an endpoint and can extend in one direction only. A ray has only one endpoint. It does not have a definite length. The arrow shows that it goes on and on in one direction. We denote the array CD as given here. More about lines. Parallel lines. The lines on a plane that never meet, no matter how far they are extended, are called parallel lines. They are always the same distance apart and are represented with a pair of vertical lines between the names of the line. Here MN is parallel to OP and AB is parallel to CD. Symbol two vertical lines is used to show is parallel to. We can see parallel lines in a zebra crossing, the lines in notebook, and in railway tracks around us. Intersecting lines. The lines that cross each other at a point are called intersecting lines. As you can see here two lines AB and CD intersect at point M. Measuring line segment. Line segments can be measured using a ruler or commonly called scale. One edge of a ruler is marked in centimeters and other edge in inches. We measure line segments in centimeters, and as shown above, each centimeter is divided into 10 equal small divisions. Each centimeter is divided into 10 equal small divisions. Each small division is called a millimeter. Thus, 1 centimeter is equal to 10 millimeter. Let us take a line segment PQ and measure its length. Place the edge of the ruler along the line segment PQ, keeping the 0 centimeter mark at P. Read the mark on the ruler at point Q. So Q coincides with 5, here PQ is equal to 5 centimeter. Thus the length of the line segment PQ is 5 centimeter. Smart tip: one and only one line can be drawn passing through two fixed points. An unlimited number of lines can pass through a single point. Drawing a line segment of given length. To draw a line segment of any given length, we follow these steps. Step 1. Place the ruler on the sheet or your notebook and hold it firmly. Step 2. Mark a point 0 with a finely sharpened pencil and then mark a point at 3.8 centimeter. Step 3. Slide the pencil gently along the edge of the ruler from 0 to 3.8 cm without moving the ruler. Step 4. Name the line segment as AB. AB is equal to 3.8 cm. Thus, we have drawn a line segment AB of length 3.8 cm. Open and closed figures. Open figures that start at one point and end at another point are called open figures. Look at the following open figures. Closed figures. Figures that start and end at the same point are called closed figures. Look at the following closed figures. Simple closed figures. Look at the following figures. Which of the figures given above could we draw by starting at same point, never lifting your pencil from the paper and end at the starting point? Obviously A, B, C, D, E, F, G and H. Such figures are called closed figures. Out of these, which figures can we draw without having the figure closed itself? Obviously A, B, D, H. Such figures are called simple closed figures. Polygons. Look at the figures below. They are all closed figures, but there is a difference. What is it? Figures A, D, E and F are made up of straight lines only, but B and C are made up of curved lines. Figures made up of only line segments as their sides are called polygons. Polygons are named according to the number of their sides. A polygon is a plain closed figure having 3 or more sides. Some examples of polygons are given below. So 3-sided polygon is called a triangle. Polygon having 4 sides is a quadrilateral. 5-sided polygon is a pentagon. 6-sided is hexagon. 7-sided is heptagon and 8-sided polygon is called an octagon. Angle. When two raised lines or line segments meet at a point, an angle is formed. In the given figure, two rays OX and OY meet at a point O and an angle is formed at their meeting point. The point where these rays meet is called the vertex, and the rays form the arms of the angle. An angle is denoted by the symbol given here. An angle is given its name in two ways. First, using a single capital letter at the vertex such as angle A. Using three capital letters with the vertex in the middle such as angle BAC or angle CAB. Interior and exterior of an angle. The inside of an angle, that is, the region between the rays, is called the interior of the angle. The point of the plane that do not lie on the arms or on the interior of the angle lie to the exterior of the angle. Look at the figure below. The points A, B and C are lying in the interior of the angle PQR. Points D and E are lying in the exterior of the angle PQR. Circle. We have already learned about the circle. It is a shape made up of a curved line. Circle is a curved shape with all its points lying at the same distance from a fixed point, that is center. Drawing circles. We can draw a circle with the help of a bangle or a bottle cap and also with the help of some coins which are circular. Place the bangle, coin or bottle cap on paper and trace around it with a pencil. We can also draw a circle with the help of a pair of compasses. A compass is an instrument in a geometry box. The compass has a metal point on one arm and on another arm a pencil can be attached. The arms can be stretched. Use these steps to draw a circle with the help of a compass. Keep the metal point of one arm fixed on the paper. Stretch out the arm that holds the pencil. Keep the metal point fixed and move the pencil arm around it. By stretching the arm more, we can draw a bigger circle, and by stretching it less, we can draw a smaller circle. Parts of the circle. Center. The point at which we had kept the metal arm of the compass fixed can be marked as O. The point O is called the center of the circle. Radius. If we join any point on the circle to the center of the circle, we get a line segment. This is called a radius of the circle. Here, OP, OM and OR are the radius of the circle O. Radii is the plural of radius. If we measure OP, OM and OR, then we will find that they all have the same length. These are the lengths of the radii of the circle O. Chord. If any two points on a circle are joined, we get a line segment. This is called a chord of the circle. Here, AB and CD are the chords of the circle O. A circle has many chords. Chords can have different lengths. Diameter. A chord of a circle which passes through its center is called a diameter. Here, MN and PQ are diameter of the circle O. A circle has many diameters. All diameters have the same length, so length of MN is equal to length of PQ. Smart tip. Every diameter is a chord, but every chord is not a diameter. The diameter is the longest chord in any circle. A circle has many radii, chords and diameters, but it has only one center. Circumference. The length of the boundary of a circle is called its circumference. We cannot measure the circumference of a circle with the ruler, though it is the length of the boundary of a circle. Drawing a circle of given radius. To draw a circle of radius, say 4 cm, we follow these steps. Step 1. Open the legs of the compass to 4 cm using ruler as shown here. Step 2. Mark any point O on the plane of the paper and place the tip of steel end at it. Step 3. Hold the head of the compass steadily and rotate it such that the pencil end touches the paper. Thus, a circle of radius 4 cm is drawn. Relation between radius and diameter. We can see that AB is the diameter of a circle O. Here, AB equals to AO plus OB. AO and OB are the radii of the circle O. So, AB is equal to radius plus radius. Here, AB is the diameter. Thus, diameter is equal to radius plus radius equals to twice of the radius. Diameter is equal to 2 into radius, or radius is equal to diameter by 2. So students, Let's start a new chapter, chapter number 8, Geometry. So students, let's look at example number 1. The radius of a circle is 3 centimeter. Find its diameter. So let's start. So we are given the radius of the circle as 3 centimeter. So we know that diameter of a circle is twice the radius of the circle, as radius of a circle is the line from the center of the circle to the circumference is radius, whereas diameter is the line, is the chord that passes through the center of the circle, whereas diameter is the chord passing through the center of the circle. So diameter of circle is twice the radius of the circle. So we can say twice into radius is 3, so 6 centimeter. So the diameter of the circle is 6 centimeter. Solid shapes. Solids can be of various shapes. The outside of a solid is called its surface. The surface may be plane or curved. A solid object is defined by number of faces, edges, and the vertices it has. A face is a flat side of a solid. An edge is where two faces of a solid meet. A vertex is a point where two or more edges meet, as shown in the figure. Some solid shapes are described here. Cube. A cube has 6 flat faces, 12 edges, and 8 vertices. All the 6 faces of a cube are squares. Cuboid. A cuboid has 6 flat faces, 12 edges, and 8 vertices. All the 6 faces of a cuboid are rectangles. Cone. A cone has 1 flat face, 1 curved face, 1 curved edge, and 1 vertex, as given in the diagram. Cylinder. A cylinder has 2 flat faces, 1 curved face, and 2 curved edges. You can see in the diagram. Sphere. A sphere has only 1 curved face, it has no edges and no vertices. Nets. Net of a cube. Take a cubical object and trace all its faces on a sheet of paper. What is the shape of all the 6 faces? They are all squares of the same size. Thus we see that a cube can be made from 6 squares joined together in a particular manner. A net is a 2-dimensional figure that can be folded into a 3-dimensional object. We have many more nets, arrangement of these squares that can be folded up to form a cube. We can also form nets with 5 square faces. In this case, it will be a box with no lid. Different views of 3D objects. A 3D shape can be viewed from the top, from the side, and from the front, and these views can be combined to visualize what the solid looks like. If we look at a cube from the top, front, and side, what do we see? We see that all the views are same. Top view, front view, and side view. We see that all the views are different. Top view, front view, and side view. Now let us see the different views of a brick. Try to look at some objects around you from different views. Try it with your tiffin box, water bottle, pencil box, and so on. Smart tip: when a solid is looked at from top, the view seen is called the plane. The front view is called the front elevation, and the side view is called the side elevation.